class. Today we're going to be talking about the standardized normal distribution, or the Z-curve. We're going to be talking also about some Z-scores, how to find them, and how to find percentiles, which is going to be kind of going backwards from our Z-scores. So we're going to start here with just a basic definition of a normal model. A normal distribution is going to apply for quantitative data sets, so numerical data, and all the normal distributions are going to be bell-shaped, unimodal, and symmetric, but not all bell-shaped distributions are normal. So be really careful about that distinction. All normal distributions are bell-shaped. Not all bell-shaped distributions are normal. So in addition to being bell-shaped and unimodal and symmetric, the normal distribution also, and I'm going to go back up in a second, also has to follow what we call the empirical rule, or the 68, 95, 99.7 rule. So we're going to get to this in just a second, but just know that that is part of the definition of a normal distribution. In AP Stats, we're going to represent the standard normal model by using this notation here, where, so we have capital N and then parentheses, mu, and then comma sigma. Mu is going to be the population mean and sigma is the population standard deviation. Right, and then let's see, let's go down here. So there's some examples here. Again, you can read some of the notes. There's more in the notes than I want to spend time doing in the video. But here we're going to talk a little bit about the standard normal distribution. So that's specifically what happens when the mean is 0 and the standard deviation is 1. So if our mean is 0, mu is 0, and standard deviation is 1, we call that the standard normal curve. And what this does is it actually gives us Z-scores. So when you see a Z-score, it's taking that normal distribution and standardizing it. All right, so let's get to this empirical rule. It applies to all normal models. If this doesn't apply to your model, then your model is not a normal model. Now, granted, in real life, not everything is going to be perfect or exact. So as long as the numbers are close to this, it's okay to call it approximately normal. We're going to see that a lot in this class. So, which is another reason why it's super important to note that each one of these lines has the word approximately in front of it, because, well, this is an approximation and also nothing's really perfect in real life. So approximately 68% of the data are within one standard deviation from the mean. So above and below, if you take all that data, you're going to get approximately 68% of your data. Approximately 95% of the data is within two standard deviations of your mean, and approximately 99.7% of the data are within 3 standard deviations from the mean. So if we look at this, I've already pre-populated this curve with a little bit of information. Mu, which is our population mean, is right in the middle. That average is in the middle. I've counted by standard deviations going out, positive and negative, and corresponding values for Z-scores are underneath that. Now, if we look at our empirical rule pieces here, I'm going to use a purple pen. This from here to here, so within one standard deviation of our mean, is going to be 68% of the data. Between here and here is going to be 95% of the data, so within 2 standard deviations, and within 3 standard deviations, we get 99.7% of the data. Notice it's not 100% of the data because, well, it's just going to keep going infinitely. Sorry, my arrow got a little weird there. But almost all of our data, if it's a normal model, is going to fall within 3 standard deviations from your mean. Now, one of the things we're going to do in this class, and which really helps us when we're solving these problems, is it's good to memorize these 3 values, but I've had students also memorize the next 4 values. It just makes calculations a little bit easier. If it's perfectly symmetric, which it is in the normal model, and we have 68% in the middle, then I can split those up and make that 34% and 34% in each one of those little sections. And then to get this section here, I can take my 95%, subtract my 68%, and divide that by 2. So I'm taking 95, I'm taking out the middle 68% that I don't want anymore, and then I have 2 sections left over, and half of that is going to give me 13.5%. Similarly, I can take 99.7 minus 95 and divide it by 2, and I get 2.35%. Oops, we can write those over here as well, 13.5 and 2.35%. And then if that's 99.7% of the data, then if I take 100 minus 99.7 and take half of that, I'll get 0.15%, 0.15% for those little bits that just keep going. So I've had students memorize these numbers as well. It does help a little bit in your calculations just to make things go a little bit faster. Okay, on our next page, we have to be really careful about using the normal model. Not everything is a normal distribution. And in AP Stats, we want to make it very, very clear that we've met conditions before using anything that's specific to one certain distribution or type of distribution. So before we can use z-scores or apply these numbers from our empirical rule, we need to verify that our data has a normal distribution. Which means we really just need to make a statement if we are given the information. Later in this course, we're going to learn different ways of determining if it's a normal model if we aren't told that it is. But for right now, you're just going to be told that it's a normal model. So what that's going to look like, for example, let's look at number 1 here. Suppose a normal model describes fuel efficiency in miles per gallon of cars currently registered in California. So it says a normal model describes this. So we want to make a statement, something like fuel efficiency in miles per gallon is stated to follow a normal model. And it's tough to remember to write this down, but it's really important in stats if you don't meet those conditions. And you can't just like circle the part of the problem where it says normal. You do need to make a statement, and that statement should be in context of your problem. Once we've done that, now I can use the empirical rule. I can use these scores if needed, which we'll go over next. So between what mile per gallon would you expect the central 95% of the cars to be found? So remember, it goes 68, 95, 99.7. So 95% is going to be within 2 standard deviations of our mean. So if I go 1 to this direction and 1, to this direction, I'm going to get that 95%. So we can see the answer there. It's going to be between 12 miles per gallon and 36 miles per gallon. But we have to be really careful. This answer isn't quite good enough because these are all approximations. So we need to say that it's approximately. And that's really important. I'm going to highlight approximately here because it is very important that we remember these are approximations. They're not exact values. All right, and then part B, what percent of all cars get less than 18 miles per gallon? So there's a couple ways you can do this. If we're using all those small values, we can simply add them up. We could do 0.15 plus 2.35 plus 13.5 as anything less than 18, or we could do 50% minus 34%. So if we take the lower half and just subtract that 34% that we have, it's just an easier way to get to our answer. So it's going to be about, now I use the word about instead of approximately because it's shorter and less to write, and it gets across the same point. It's not exact, but it's about 16% for that portion. All right, I'm going to skip the next couple examples. You can get these off of the filled in notes from our course calendar, and we are going to go to the next page here. and kind of halfway down the next page. So you won't always be able to use that empirical rule and all those percentages we went over. You really are only going to be able to use those if you have whole number standard deviations or whole number z-scores in your problem. So what happens when we don't have whole number z-scores? So we're going to look at an example here. Example 4, scores at an ugly cat competition followed an approximately normal distribution where, and then we've got that format here. We have a mean of 700 and a standard deviation of 100 for those scores at the ugly cat competition. So before we do anything, we need to make our statement that verifies that this is a normal distribution. So we can say something like scores are stated to follow an approximate, and we are all about abbreviating or shortening our words, as long as it's still pretty obvious what that word was, follow an approximately normal distribution. So again, I'm shortening things. All right, so what percent of cats scored below 680? So if I think about this, let me draw a little picture. It always helps to draw a picture. So if I have 700 here, and I have a standard deviation of 100, then if I go one standard deviation above, I get 800. If I go one standard deviation below, I get 600, but I didn't want one of those. I want 680. So if I have 680, it's going to be somewhere here, 680, and I want the percent of cats that scored below 680. So I know that my z-score is going to be negative because I'm below the mean, and I know it's going to be less than 1 z-score below the mean. And we can use our z formula to find the z-score. Now, I went over the z formula in our last lesson, so you might want to go back and watch that video if you haven't yet. Z equals my data value minus my mean over my standard deviation divided by the square root of n. Now, we talked about this last time. Right now, we're just going to use n equals 1 because we're not given a specific sample size more than 1. So right now, we're just going to do x minus mean over sigma. But later, we will pull that n in when we start getting larger sample sizes. All right, so z equals 680 minus our mean of 700 divided by our standard deviation of 100. So that's going to be negative 0.2. Which makes sense based on my picture. I'm a negative z-score. I'm just a little bit below that mean, definitely less than 1 standard deviation. And this is where we have a couple options. Now, our calculator can actually do this for us, but I'm going to show you how to use your z-table because I feel like it's a little bit more conceptual. In class, I can show you how to do that calculator work. All right, so on the z-table, and you can get this on our Google Classroom. You can also just search for it. These are the AP Statistics formula sheets for the AP exam. I have z-tables full of values and probabilities. And if you notice, I can't mark this, but you can kind of see where I am on my screen. This shaded region is going to be what all these numbers represent. They represent the area of that shaded region, the probability below that value for z. There are 2 pages to your z-tables. There's a negative z-score page and a positive z-score page. So just pay attention to which one you have. I have a z-score of negative 0.2. So negative 0.2. There we go. So negative 0.2. And I don't have a second decimal. If I had a second decimal, I could travel across this table a little bit to find that hundredths place. So right now, I'm just going to look at this number right here. I have negative 0.20. So this is going to be the probability or that area below that value. So 0.4207. So this is going to be 0.4207 or approximately 42.07% as our answer. And then let's just do a couple more here. What percent of the cats scored more than 810? So again, I'm going to draw a quick little sketch. It doesn't have to be super detailed. I have 700 here, 800, and then 810 is just above that. So I want to shade based on what it says. If I don't draw a picture in shade, half of the time my students end up giving me the wrong answer because they go the wrong direction. So it's always good to draw a quick little picture, do your shading so that you have a visual representation of which direction you want to go. So the first thing I'm going to do is find my z-score, 810 minus 700 divided by 100. Again, my n is just 1 right now, so I'm not going to worry too much about that sample size. And this is going to be 1.10. So I'm going to go to my z-score table, my z-table, and I'm going to go down to the positive page, and I'm going to find 1.10, which is this number right here, 8413. So I'm going to write down 0.8413. Now this is where the shaded picture comes in handy. If you box that as your answer, it doesn't make any sense. Look at the shaded part of your graph. That can't be 84%. It's less than half. It's a smaller section. If I go the other direction, from here down, I get 84.13%, but that's not what the problem was asking me to find. So again, really good reason to draw your quick picture and shade that spot. So to get the above proportion, I'm just going to subtract that from 1. 1 minus 0.8413, and I get 13.567, I believe, percent there. All right, and then percent of cats that scored between two values. What we're going to do here, so I'm going to draw a quick sketch. So I have 700, 770, and 670. So I'm going to have, 670. So I'm going to have one positive and one negative z-score. I want the percent between them. I'm going to speed up here a little bit. So my z-score, I'm going to do two different z-scores, one with the 770 minus 700 over 100, and the other one with the 670 minus 700 over 100. So I'm finding two separate z-scores. I'm going to get 0.7 and negative 0.3. Then I'm going to find both percentages corresponding to each one of those. So what percent goes below this one and what percent goes below this one here, and then I can subtract those two percentages. So we don't subtract the z-scores. We find the percentages separately and then subtract the percentages. So going back to our table, I have a z-score of 0.7, which is this here. 0.70 is 0.7580. So 580, and then a z-score of negative 0.3. I'm just going to go back up to the negative 0.3 is going to be here, 0.3821. 0.3821. And when I subtract those two pieces, let me grab my calculator here, 0.7580 minus 0.3821 is 37 or 0.3759, which is 37.59%. All right, now, a couple things. I didn't do approximately. In AP Stats, when we use the empirical rule, which is the 68, 95, 99.7, those values are less accurate. So we really have to use approximately or around or about when we write our answers. When we use our z-table or our calculator values, it's a lot more accurate, so I don't have to put approximately. It's never a bad idea to do it anyways. It never hurts to do a little approximately symbol in front of your answers. All right, last page. We're going to go over percentiles really quick. A percentile is the percentage of the data that lies at or below the percentile value. So it's similar to z-scores, but it's kind of like going backwards. Note, so if I have a score of 135 is at the 85th percentile, it doesn't mean that 85% of the data is below 135. It means 85% of the data is at or below 135. So there could have been a whole bunch of people that also had a score of 135 in that 85%. So be careful about that a little bit. Right, IQ scores follow an approximately normal model with a mean of 100 and a standard deviation of 16. So again, we just want to make a little statement. It's stated that IQ scores follow an approximately normal model. Okay, find the score that lies at the 80th percentile. So just to visualize what that means, 80% at or below. So I want 80% at or below, and I want to figure out what IQ score that is. So the first thing we're going to do is take that 80% and find the z-score that corresponds to that value. So I want to go to my z-table, and I know it's going to be a positive z-score because 80% is more than 50%, so I'm above my mean. So I'm going to go to the positive values, and these are all in numerical order. I'm going to find the number that's closest to 80%. Now, we have two of those numbers. We have 0.7995 and 0.8023. Which one is closer to exactly 0.8? We're going to use that, which is going to be this one, 0.7995, and that's going to give me a z-score of 0.84. So if you notice, this is 0.8, and then up here is 0.04. So there's that second decimal we want for the z. So 0.84. So z equals 0.84. If I did that right, I'm just going to double check that that was right. Yes, 0.84. Okay, and then I'm going to use my z formula. So z equals x minus mu over sigma. And again, we don't have to use that over square root of n right now because n is 1. And I'm going to plug it in. So 0.84 equals x minus 100, mean of 100, divided by standard deviation of 16. And then I can solve for x. I multiply both sides by 16. I'll do it like this. And let's see, 16 times 0.84 is 13.44 equals x minus 100. So x is going to be 113.44 as my score. Now, there is a way to do that in your calculator without using the z-table. Again, I'll go over that in class, but for right now, I want you to really see that conceptual curve with the shading and everything else. All right, I'm going to quickly go over these really fast. I probably won't do all of them. Just really quick, score that corresponds to Q1. So now we're bringing in some information from before. Q1 is the first quartile, which means if we think about our like our box plots, this is where we saw Q1 here. Q1 is where 25% of the data is below or at Q1. So that's going to be the 25th percentile. So what you want to do is find whatever x value or z-score first, such that 25% is below it. I'm going to not do the rest of the problem because it's almost just like the one we did. We had 80%. Now we're going to be looking for 25%. You're going to get a negative z-score and work from there. The z-score that corresponds to the top 5%. So top 5% means 5% this way. And I want that value. But if you look at all the pictures on the z table, if we look at all these pictures here, all the shading is lower. So all the probabilities and the area values are all the amounts shaded below that value. So what you want to do here is figure out how much has to go below that to give you the top 5%. And so that's going to be 95% below. So I'm looking at the 95th percentile value here. So I'm going to find that 0.95 area for 95%, find the z-score, work backwards from there. And then the middle 40%, just to set you up here, wow, that's a horrible curve. It's a little bit better. So the middle 40%, if this is my mean, then I want 20% here and 20% here. So I want this value and this value. Think about what percent has to be below those. If this is 50% below the mean and that's 20, then I have 30% here. So this is the 30th percentile. And then this one, if I go 20 above the mean, that's going to be 70%. So the 70th percentile. So you can use the z-scores to find those, the z-table to find those z-scores for those percentiles, and then work your way backwards to an x value. And that's it for today's lesson.